now.
Recording in progress.
Okay. I will share today's slide. So, so today we will be continuing science instruments that we didn't finish last time. And we will move on to energy and energy transfer. So here is a video that introduces scientific instruments. Yeah, so this was a short video that introduced different types of scientific instruments. So we saw, beakers, graduated cylinders. We also saw things like test tubes, and those are all used in the lab for measurements. And here I have listed some methods to separate a mixture. So one way that we can separate a mixture is by filtration, which separates solid particles from liquid or gas using a filter. Another way is by separating funnel. It's when it separates oil and water from two separate layers. And we have magnetization, which uses magnetic attraction to separate mixtures. And finally, we have distillation. And distillation is when it separates a liquid from mixture of liquids. So when we have two mixtures of liquids, we separate them by boiling points. And we will get to this in just a little bit, but these are the main four methods of separating mixtures. I'll let you guys write down a little bit and then I can move on. Um, Okay, so let's look at, well, first, different types of matter. So when I say mixture, I mean a homogeneous mixture or heterogeneous mixture. So mixtures, you can see there are homogeneous mixtures, which are mixtures that mix really easily, that is evenly throughout. There are no clumps like salt water, mouthwash, alloys, all of those are homogeneous mixtures. Heterogeneous mixtures do not mix properly. There may be some clumps, or it may not be evenly distributed. Things like pizza, salad dressing, landfills, soils, all of those are heterogeneous mixtures. So these are just two types of mixtures. But matter, like we learned last time, remember last week, we learned about pure substances like elements and compounds. Remember how pure elements were only made out of one atom. So one atom type, since like oxygen, hydrogen, potassium, all of those are made out of single atom. So it's a pure element. And we also learned about compounds. It's a molecule that forms when there are more than one atom. Things like water, H2O. So water is H2O. There's two hydrogen, one oxygen. And we also learned about things like sodium chloride forming a compound. There's a sodium and a chloride. There are more than one atom. And carbon dioxide, CO2. Can see carbon dioxide. has one carbon and two oxygens. And these are called pure compounds. So this is the general outline of what matters can be. And it's important to know this because just talked about separation methods, right? Separation methods are used to change mixtures into pure substances. Here, separation methods to change from mixtures to pure substances. That's why it's really important to know how to separate mixtures. So yeah, I hope this makes sense for everyone. And I will be moving on to, well, here's just a description of what pure substances. We talked about this. It is made out of only one type of material. So pure means only one type of any material, and that it cannot be separated into other substances by physical methods. It needs to change through chemical reactions. It needs to change through chemical reactions, not through physical methods. Okay. And types of pure elements we already talked about elements and compounds, so they're clear, right? Elements, one type of atom, compound, two or more types of atoms. Now we can move on. And again, mixture. It's made up of two or more substances mixed together. But remember, mixtures are not mixed together chemically, not chemically. And mixture can be easily separated, like filtering, boiling. And again, homogeneous mixture, heterogeneous mixture, we already talked about. Homogeneous, uniform composition, mixed thoroughly. Heterogeneous mixture, not mixed thoroughly. And does this make sense for everyone? Does anyone have any questions so far? Um, if you have no questions, then I think I have a couple questions for you to answer. So here is an example question. So a substance which is made up of the same kind of atoms is called, is it a compound? Is it an element? Is it a mixture? Or is it an ion? Does anyone want to answer this first question?
Element.
I heard A, maybe a compound, but here, did you say A?
B.
Yes, that is right. The answer is B. You're correct. Because we look here again, pure elements are made up of only one type, and compounds are made up of multiple, two or more. So B is the correct answer. Element has only one type of atom. Yes, the same kind of atoms is called an element. And now let's look at the second question. Which of the following substances is a compound? You're asking about compound. Is it oxygen? Let me write it. Just oxygen. Or is it Magnesium.
Oxygen.
Do you really think oxygen is a compound? Remember, compound, there are more.
Water.
Oh, yes, that is right. I think it's said water. It's H2O. Um, when we think of oxygen, oxygen exists as O2. But since it's made out of same kind of atom, oxygen is still an element. But water, you can see, it is made out of two hydrogens and one oxygen. So since there are more than one kind of atom making water, water is a compound. So C is the correct answer for this. That is right. Yeah, these are just sample questions from the BECE test, which you will take at the end of junior high school. So, um, so it's a really good preparation for you guys. And here I had another question, but I will help you through this because some of them have a little difficult compounds. So, which of the following substances is a compound? It's asking for a compound again. So copper is just Cu, one type of atom, so it's an element. Diamond, so diamond, it may be confusing because you might be wondering, what are diamonds made out of? Well, diamonds are made out of carbon, essentially. They are really structured carbons that is really, really hard to break. But diamonds are still carbon. So it's made out of one type of atom. So it's called an element, not a compound. Sucrose, however, is made out of 12 carbons, 22 hydrogens, and 11 oxygens. You don't need to maybe memorize entirely, but you can see sucrose is made out of one, two, three types of atoms. So that is why sucrose is a compound. Okay. And finally, sulfur is just S, one atom, one type of atom. So it is an element, not a compound. So that is why sucrose C is correct. Yeah, I hope this makes sense for everyone. Yeah, always let me know if you have any questions or stop me if you're writing down something and I'm happy to do so. So let's move away from elements and substances and move on to ways of separation. So first thing we talked about was filtration. Remember, filtration is usually for separating liquid and solid. So can everyone see this picture here? On the picture, you can see that a beaker containing a mixture of liquid and solid are being poured into this funnel. So into this funnel, and then it flows down this filtration paper. You can see over here. Once it flows down the filtration paper, it filters out the residue. The residue are just solid particles, here you can see, that gather once the liquid is poured out. And then finally, the liquid is collected in the filtrate. On the right, here's a simpler picture. So here's a mixture. It is poured in through the filter paper, through the filter tunnel, and then finally we are left with solids on the top, liquids at the bottom. Because filter paper is semi-permeable. It means that it only lets some things through. In this case, it only lets liquid through, and it leaves solid on the filtration paper. And solids that gather are called the residue. It's the residue. And the liquid that gathers is called the filtrate. These are two vocabulary that you need to know. Residue and filtrate. So let's look at an example question to see if you guys understood the filtration method. So the solid component found on the filter paper and the liquid component that flows into a container during filtration are respectively called. So here is asking about solid components and liquid components. What are they called again? Do you guys remember? Okay, let's start with, yeah, solid first. What is solid component called? Yeah. Yes, it's called the residue, right? It's called the residue. And liquid component is called, I think I heard C, which is right. Um, the liquid component is called the filtrate. So that's why the answer is C. There is a solid component called residue and a liquid component called the filtrate. Yeah, good job for everyone getting this question right. Yeah, this was a question about filtration. Answer is C. And now, this is the second way of separating mixture. It's by a separation funnel. And it looks something like this. And it usually separates two liquids that don't mix, like water and oil. Do you guys know that water and oil do not mix together properly? They form these two layers and they don't really mix well together, and we can separate them. So let's look at this video. This shows you how separation funnels are used. So this will be another short one.
Start by mounting the separating funnel in a retort stand. Ensure the tap is closed and then add the reagents. Here we have an aqueous solution, followed by an organic solvent. Place the lid on the separating funnel and then remove from the stand. Agitate the separating funnel to combine the reagents. Depending on the experiment, you may need to do this multiple times. During agitation, Pause to invert the separating funnel and release any gas build-up through the tap. Make sure to keep the lid firmly in place during this. The contents can now be left to settle into layers. The aqueous and organic layers are now ready to be separated. Remove the lid to prevent a vacuum forming, and then open the tap to begin draining off the lower layer. Close the tap at the meniscus when the lower layer has been removed. The lower layer has now been separated into the beaker below, with the upper layer inside the separating funnel.
Yeah, so I hope everyone was able to see how separating funnels were used. So here you can see, can everyone see two layers of liquid? Here is this purple layer on top and this yellow liquid at the bottom. And separating funnels are used to separate these two liquids. You can see this person twisted the knob to let only the bottom liquid through. And that is how he was able to separate two liquids. Yeah, that was the separating funnel. Oh, and it's important to know that the liquid with low density goes on top, and liquid with higher density goes at the bottom. And that is how it forms a different layer. So, okay, let's solve a question to see if everyone understood the concept. So, the use of separating funnel is most appropriate for separating which of the following mixtures? Is it sulfur and water, water and sodium chloride, vegetable oil and kerosene, or water and vegetable oil? Does anyone want to try this question? Oh, yes, that is correct. D is the right answer. Yeah, great job. It's water and vegetable oil because they do not mix together and they form two layers. So that is why they can easily be separated by a separating funnel. Yeah, that is right. And this question is just about magnetic attraction, another way to separate mixtures. So yeah, the process used to separate mixture of iron fillings and sulfur is would it be magnetic attraction, sublimation, distillation, or evaporation? Yes, that's right. I kind of already talked about this, but it's magnetic attraction. Remember how iron fillings are attracted to magnets, but sulfur is not. So when you have a mixture of iron fillings and sulfur, you can easily separate the two substances by magnetic attraction. This person is using a magnet to separate the iron from the sulfur. Okay, that was magnetic attraction. And finally, one last thing I want to talk about for mixture separation is distillation. So this is kind of important. So distillation, remember, is used to separate two liquids that are combined, but it's different from separating funnels because we are now using boiling points to separate the mixture. So boiling point is when the liquid turns into gas. When the temperature the liquid turns into gas is called, in degrees Celsius, the boiling point. So let's say this liquid has a combination of one liquid that boils at 50 degrees Celsius and another that boils at 80 degrees Celsius. So if we put the burner up the temperature, we set the burner to 60 degrees Celsius, right? When we have a burner of 60 degrees Celsius, which one will boil? Let's call this A and this B. Which one will boil first? It will be A, right? Because A have a lower boiling point. So when A turns into gas, only A turns into gas. And it builds up through this condenser. It turns it back into liquid. Then it is settled down at another flask. So this is how distillation works. I will explain it a little more on the next slide, but this is the general distillation apparatus. This is the structure of how it works. We have a burner, we have a flask in the left containing the mixture, a thermometer to check the temperature, condenser to change the gas back into liquid, and then another flask on the right to gather that liquid. So, okay. Here is just describing the method. I said it simply before, but here, the general sense is that you heat the mixture so that, number one, heating, so that the mixture is heated in the distillation flask. And let's look at this scenario where alcohol has 78.3 degrees Celsius boiling point, and water has 100 degrees Celsius boiling point. So which one will evaporate first? It would be alcohol, right? Because it has a lower boiling point. So second, alcohol evaporates first. Since alcohol has a lower boiling point. And then the third step is condensation. So the alcohol that has turned into gas passes through this condenser where it cools down and turns it back into liquid. That step is called condensation. And finally, we have collection. It's when this condensed alcohol is collected on the receiving flask, all the way on the right. So if we look at here and go back to this picture, left is heating step. And on the top here is the boiling step. In the middle is the condensation step. And on the right is the collection step. So the final result is that on the right, the collected liquid is alcohol. Since only alcohol was evaporated, and the remaining liquid on the left flask is the pure water. So this was quite a lot to maybe comprehend, but I hope everyone is able to understand, and this whole process is called, again, distillation. It's called distillation. So, yeah, does anyone have a question? Because, again, this was a lot. Um, and yeah, I will wait a little bit, maybe for some people to write down this slide. But okay, so I hope everyone was able to write down a slide, and I can always share you the slides so that maybe the teachers can help you write it down. I will send this to you. But let's look at this final question. So, a mixture of alcohol and water can best be separated by, is it filtration, condensation, distillation, or evaporation?
C.
Yes, that's right. The answer is C. We just talked about distillation, and it's used to separate alcohol and water. It's a classic example because they have distinct boiling points. So these two liquids can be separated by condensation. That is correct. By distillation, sorry. Let me move this. By distillation. Okay. Yeah, I hope everyone was able to understand. And this, if no one has a question, I will move on to the next topic and you can let me know. So this one is a shorter topic about energy transfer. So yeah, let's look at what are we learning today. So here in this topic, we're learning about energy. What is energy? We will also learn about energy transfer. We will learn about type of energy. We will learn about renewable energy. And we will also learn about heat transfer, like conduction, convection, and radiation. So let's look at this video. It's a fun video where it generates a lot of experiments that you can see. Yeah, so that was the video for energy transfer. So what we have noticed in the video, energy is the ability to do work. So energy makes things move, light up, heat up, or even grow. And energy cannot be created or destroyed. Energy can only change from one form to another. And this is so important that it's made a law, and it's called the law of conservation of energy. So energy cannot be created or destroyed. It can only change from one form to another. And a type of energy, there are many different types of energy. But here I listed some examples. Things like kinetic energy, potential energy, heat energy or thermal energy, light energy, electrical energy, chemical energy, sound energy, nuclear energy. All of these are different types of energies. And this is not the end of the list. There are many, many more types of energy. But remember how energy transforms from one form to another. Regardless of what type of energy it is, it can transform always from one to another. So let's look at some examples here. If you have an electrical outlet, just the electrical energy, and connected to things like um, maybe you have it charged in your computer, or you can connect it to TV, television, or you can connect it to anything. Let's say a light bulb too, it changes from electrical energy to sound and light energy. That's one transformation. You can also use a generator to transform mechanical energy to a light bulb, for example, of electrical energy. We can use fuel from chemical energy to change into mechanical energy for cars to move. And things that we eat, like food, have stored chemical energy. So every food has stored chemical energy. And when we eat the food, we are able to move around, which basically transformed into mechanical energy. And there are many, many more examples, many different combinations that you can kind of guess. But here are just some examples of how energy can change from one form to another. Okay, so let's look at this question about energy transfer. So it's also from the BECE exam. So which of the following electrical appliances can convert electrical energy to heat energy? So we have three options: electric iron, kettle, and water heater. So which of these convert electrical energy to heat energy? Does anyone have an answer or
A.
yes, that is right. Yeah, great job. The answer is A. All of these, one, two, and three, convert electrical energy to heat energy. Because all of these are plugged in. Basically, you can plug these in to the electrical outlet, and it uses electrical energy from the outlet to convert to heat. So it's all three of these. Great job. And Let's look at this question next. In which of the following devices is electrical energy transformed into light energy? So we are looking at electrical to light. What can do this? Is it electric bell? Is it fluorescent tube? Is it a lantern? Or is it a radio? And fluorescent tube is something that looks like this.
B.
And yes, that is right. All the rest does not involve really electrical energy. Fluorescent tube uses electrical energy that is connected to the outlet. Here is a wall with outlets that you connect it to. And then that electrical energy is converted, transformed into the light energy that we see. It's like a bulb. But the rest of these, it doesn't really make sense. Not an electric bell. Bell is more of like a mechanical energy. Lantern actually uses um things like fire inside, maybe a heat energy to make light energy, and then it's not radio. So the only answer is B, fluorescent tube. Yes, so here lists the examples. Okay. Let's look at a couple more questions just to settle in on this energy transformation question. So the energy transformation that takes place in solar cell is what? So solar cell is when we use the energy from the sun. So is it light to chemical or is it light to electrical? Is it light to heat or is it electrical to light? Yes, I heard B, and that's correct. Um, because the energy from the sun comes as a light energy. So solar cell converts sunlight as a light energy, and it converts it eventually to electricity or electrical energy. So yeah, that was the solar cell. So you just need to know what a solar cell is. It's something that looks like this that converts light to electrical. That is a solar cell. Okay. Now let's look at this question. So the energy transformation that occurs when sodium hydroxide is dissolved in water is, so this is a different type of energy transformation since we are dealing with sodium hydroxide dissolution. So it's dissolved. So when sodium hydroxide, NaOH, dissolves in water, it actually undergoes a chemical reaction, right? And this reaction releases heat. This is a little tricky question. It's a little difficult because you need to know that this chemical reaction with sodium hydroxide produces heat and makes the solution feel hot. So,
C.
what is an example? Yes, I think I heard C, that is correct. Like I've talked about, from the chemical reaction, it stores chemical energy. But then it releases heat because it's an exothermic reaction. It feels hot. During the chemical reaction, heat is released. So this was an example with sodium hydroxide. Heat is released, and this is an energy transformation from chemical energy to heat energy. So I hope, yeah, that makes sense for everyone. And if you have questions, always ask me. But because we will be moving on to what renewable energy are. So here, renewable energy comes from natural sources that never run out. So these are natural sources that never run out and can be used again and again. And they're good for the environment because it causes no pollution. We are only using natural resources. So things like solar energy, we saw that solar energy is converted from light to electrical by solar cells, right? With solar cells. That is an example of renewable energy. We can also use wind energy. Things like wind turbines generate energy, electrical energy from wind. We also use hydropower. Hydro means water, so it uses the movement of water to produce electricity. It's really interesting, right? Um, when we use the natural water flow, and maybe here's a generator, and when water flows down, this generator spins and it creates from mechanical energy to electrical energy. And finally, we have biomass or biogas that we can use as renewable energy. It is derived from organic materials like wood, crops, and waste. So all of these, we are not causing pollution, no pollution, and we can use them again and again. So these are renewable energies. We can think about the name re again, renewable, like using renewable. Okay, so these are renewable energy. Again, we have pictures here. Solar energy, you use solar panels. Hydropower, we use water. Wind, we use wind turbines for it to spin. And there are other things like biomass, geothermal, tidal, all of these are renewable energies. So we can use them again and again. But there are also non-renewable energy. So non-renewable energy comes from finite resources. They are not infinite and they take often millions of years to form. And they can run out and they do and will run out eventually. But the problem is that they can cause pollution. Some examples of non-renewable energy are coal is a main non-renewable energy. It's a fossil fuel that is used for electricity generation. We also have oil. We also have natural gas. Also nuclear energy, which is mostly produced from uranium through nuclear fission. So once uranium sort of decays, it produces a lot of energy. But again, it builds of waste. It's you cannot use uranium again once it's already decayed, and they can cause pollution. And finally, we also have thermal energy as a non-renewable energy. And it is also, if it's from fossil fuels, it's not really eco-friendly. It also causes some sort of pollution. So these are examples of non-renewable energy. So again, it's finite and they can run out and they cause pollution. Okay. Now let's solve some questions so that everyone can understand this topic fully. So, which of the following pairs of energy sources is environmentally friendly? Remember, environmentally friendly means no pollution, which means renewable energy. Yeah, okay. Which of these are renewable energies? Is it coal and thermal energy? Is it wind and biogas? Is it wind and coal? Or is it biogas and thermal energy? So, does anyone want to answer this question? Or
B.
so I think I heard B, which is correct. It's wind and biogas. So yeah, great job. Wind again is renewable. We use it from wind turbines. That's right. And biogas we use that's already in the ecosystem. So all of these are renewable. So the answer is B. Yeah, good job. And let's look at this next question. So who wants to try this question? Which of the following resources of energy is non-renewable? So we have options like coal, solar, wind, and uranium. Yeah, what do you guys think is non-renewable? So coal, do you think coal is non-renewable or renewable energy?
C.
Oh, yes. I think I heard C. That is correct. Yeah, great job again, for this question. Coal is non-renewable. Solar is actually renewable. Wind is also renewable, but uranium is non-renewable. So it's C, 1 and 4 only. Yeah, the answer is C. Great job. And this last topic I want to talk about today is heat transfer. So heat transfer is when heat or thermal energy moves from hotter place to cooler place. So there are three main ways heat transfer can happen. It can happen by conduction. which is when heat moves through direct contact between materials. So example is like metal spoon gets hot when it's in boiling soup. Direct contact from the soup to the spoon. That is conduction. And convection is when heat moves through fluid, liquids or gases, by the movement of the fluid itself. So, an example is when warm air rising and cool air sinking. So warm air tends to go up, but cool air tends to go down. And it can also be water. So waters can also move from place to place. When heat is applied to water, it can be moved through the movement of fluid. And finally, we have radiation, which is when heat moves as electromagnetic waves. And radiation is just heat without matter. There's nothing in between. It's purely by electromagnetic waves. So when you feel the warmth of the sun on your skin, so when you go out on a hot day, you feel really hot, right? You feel this heat from the sun through radiation. But these were the three types of heat transfer. So here it is. Again, conduction is by direct contact. When you touch a hot object, it's conduction. Convection is when energy is transferred by the mass motion of molecules by a medium through gas, like on the right, this is gas, or by liquid. You can see energy is transferred by liquid movement as warm water goes up, and then as it cools down, it sinks back down. It's like a sort of cycle, and heat energy also moves with the cycle. And gas, similar to gas, hot air moves up, but then it cools down and it goes back down. It's also a sort of cycle, and heat energy is moved through this cycle, and that's called convection. And lastly, we have radiation, which again is transferred by electromagnetic radiation. There are these waves that we can and cannot see, and these waves are called electromagnetic waves. So, here is just a spectrum of electromagnetic waves. And you can see these different types of waves, and we can see only in this visible part, showing the rainbow. And we have, from the sunlight, we have this kind of wave, the ultraviolet wave, possibly, hitting our skin, that makes us feel hot. And all of these are examples of electromagnetic waves. So let's solve a question to get a sense. So again, we had three different types: conduction, convection, and radiation. So with these, what heat transfer is this? A bowl of water on a gas stove was initially cold. but it became warm after some time. What was the mode of heat transfer in this water? Can anyone try to answer this question? Oh, I think I heard A, and yes, that's correct. It's convection. Remember, convection is when energy is transferred by fluid movement. So as the water gets warmer, the water moves, the cold water sinks, and the hot, warmer water rises, and heat moves through this medium. And that's why the answer is A, convection. Yeah, great job answering this question. Let's look at this next question. So, the mode of heat transfer in which no material is involved is known as, is it conduction, convection, expansion, or radiation? So when, yes, that's right. The answer is D, radiation. So here, let me go back to this slide. So radiation is when heat moves as electromagnetic waves without matter. So again, we talked about this whole thing that it only spreads through this electromagnetic waves that may not be visible, and it does not require any matter in between. So that's why the answer is D, radiation. Good job. And that is the end of today's lesson. Yeah, thank you everyone for listening. So does anyone have a final question about anything we covered today? So does anyone have any questions about like um scientific instruments or energy heat transfer? I'm happy to answer.
Who has a question? No. Yes. So you understand everything? Yes. You should ask more questions. Right? All right, James.
Yes.
Yeah, they say they understand, so you can ask question if any.
Yeah, I think I asked plenty of questions in between. So yeah, I hope they were able to understand and yeah, but that was it for today's lesson. If you don't have any questions, I think the next week's topic is on economics. So yeah, next week you guys will learn about economics and
So next week, we're going to learn about economics. Do you have any question? Get prepared before he comes. I'll do it. Do you want him to display the topic for you? All right. They want you to write it, display it on your screen so that they will see the next week lesson.
Okay.
All right.
Next week's lesson is actually going to be done by my friend. Is another person will be doing economics. So here,
Okay.
next week will be on economics. So I kind of have to switch this around, but so September 26th, which is next week, we have what is economics? Who is an
Okay.
economist? So yeah, and that will be done um by my friend, another person, but I will still be there to answer questions. So yeah,
Next week is economics. It's about what is economics and what is economics about. And it will be handled by JD's friend, not himself. But JD will be online. Or is
yes.
that right? Yeah. All right.
Okay, yeah. If you don't have any questions, I'll see everyone next week then. All right. All right. Does that sound good? And yeah.
So that is all for today, right?
Yes, that's all for today.
All right. All right. So,
Okay, yeah. Bye, everyone. I'll see you next week. Bye. Monday. Bye. Bye, everyone.